On va passer à Claudio Mura. Est-ce que Claudio est là?
Oui, j'arrive.
Tu peux commencer, partager ton écran. Claudio est un étudiant au doctorat à l'Université du Québec à Chicoutimi sous la direction de Patricia Raymond, Sergio Rossi, Annie Delorier et Valentina Buttot. Il va présenter une présentation Stable Allometric Trajectories in pitch ABS along an elevation gradient.
Yes, thank you, Sergio. Hello, everyone. So you already introduced me. There is no need for that. I'll jump right in and start introducing our research question. So while we know that temperature influences tree phenology and growth, so that we find shorter growing seasons and slower growth at lower temperatures, such as at higher elevations or northern latitudes, what I asked here with this research is if there is also an effect on biomass partitioning. So do trees change their allocation patterns based on environmental conditions? For example, do trees at higher elevations grow comparatively more leaves or bigger canopies to make up for the shorter growing season? So to answer this question, we adopted an allometric perspective and looked at allometric scaling. So how different traits or processes relate to each other during growth. So here you see a typical example of an allometric equation in which the two traits y and x are defined in a relationship by two intercept and slope values. Now this kind of equation is typically log transformed into a linear regression such as this, and is usually observed with a very limited range of commonly observed variants, while this empty morphospace here represent conditions that are out of balance for the tree and usually correspond to instability or decline. For example, here we have the leaf mass against the mass of the sapwood, and point A here will correspond to a tree that underwent defoliation. And from this point, it can either grow new leaves and get back on track in the optimal balance or go towards irreversible decline. Now, we adopt this approach because by quantifying the balance of traits through this kind of equation, we can compare the slope values. And essentially, that tells us if the trees have the same trajectory during growth, if they maintain the same balance while growing in different environments. So our objectives, our objectives to wrap things up are to quantify the differences in length to growing season, to quantify the differences in growth, and to investigate the differences or similarities in allometric scaling. Now, the study area was in Norway. I was there during an exchange at the time, and we established an elevational gradient in clear-cutted Norway spruce forest. So you see that we established 4 sites, roughly every 100 meters in elevation, and we tagged 50 trees per site and placed temperature loggers in the field to record environmental differences. And oh yeah, the sites were clear-cutted in 2010. They were planted with saplings in 2012, and we did our measurements in the field in 2018. So we had access to a lot of young trees, easily accessible, easy to measure, and with roughly the same age and growing up in similar conditions in terms of exposition and soil. So the measurements we took according to our objectives were to, well, we measured the phenological stages of bud break to quantify differences in the length of the growing season. We measured the apical and radial growth every 3 weeks to quantify differences in growth. And we quantified the allometric scaling of crown volume, radius and length, and tree diameter over tree height. So let's start with the results. Here you have the sites and the result of the post-hoc test applied to the analysis of variance and the mean values here. So we see that the lower sites have warmer temperatures and bigger trees, both in terms of height and diameter, which seems pretty much in line with the elevational gradient and differences in temperature that we set up. For the bud break, we applied cumulative mix effect models, and we found that a significant positive correlation with temperature. So we confirmed that temperature has a direct effect on bud break, also under field condition. And Other variables such as tree variety or photoperiod were discarded during model selection. So according to this relationship between bud break and temperature, we did find an earlier start of the season in lower sites, which is a bit slim if we look here at the mean date of bud break, only 1 or 2 days of difference, which was still significant according to the ANOVA, and a bit clearer if we look at the cumulative percentage of trees reaching the final stage of bud break over time. So here we see that the two lower and warmer sites were a bit faster in their bud break. For the growth, however, the results were not so easy to interpret or didn't really follow the elevation gradient. So here again, we have the post-hoc test results. Here we have the mean shoot elongation, mean diameter increment, and here we have the values normalized over tree height and tree diameter. We normalized them in order to compare these values for trees of different dimensions. So we see that there are very few differences, and those differences, like between A and C for the height and A and D for the diameter, indicate that bigger trees in the warmer sites grew less than the smaller trees in the colder sites, which seems a little bit counterintuitive. Moreover, if we look at the elongation and diameter increment over time, we see this strange low value here. So the diameter increment we measured as 2 peaks and the low value in between, which is strange because we know from literature that conifers in boreal ecosystems usually tend to maximize their radial increment exactly in this period of the season, so around the summer solstice, which was on the 21st of June for this year. And so it's strange that we observed this, and it might be due to the fact that in 2018 there was an extreme drought which hit Central and Northern European forests. And it was a record breaker in terms of temperature in many Scandinavian countries, and precipitations, of course, were really low. And there's already a couple of papers out there which have quantified the impacts of this drought. So it is possible that the drought affected the growth during our season. We can't say for sure because it wasn't within the scope of our study to quantify the water content in the trees during the season. So we don't have data to say that the drought really had an effect, but it's a strong possibility, and I think worthy of mentioning, given that this kind of event is going to increase in frequency in the future and may affect tree growth. So to move on to the last part of the results, finally the allometric scaling results. So we see the plots here of the crown volume and tree height. Here you have the allometric equation with the slope and intercept parameters. And here in brackets, you have the confidence intervals of the parameters, where B is the slope and A the intercept. So we defined similarity between the parameters by overlapping confidence intervals. So we see that the values are all overlapping here and here, with a single exception of the slope value for the relationship between crown length and tree height in site A, which is slightly different and bigger than the others. This means that the trees tend to grow a taller crown, and if you look at the crown radius, it's also a bit smaller than the others, although not significantly. So this means that crowns in site A, which was the lowest and warmest, have a tendency to be narrower. And this again is a bit strange because normally spruce tend to grow narrower crowns in colder climates and not warmer climates. But we observed in the field that there was much stronger competition with birch, Betula, pubescens in the lowest site, and this might have driven trees to develop narrower crowns. This is again not really supported by data for our study, but it's the explanation we have. And moreover, you notice that the higher value, higher slope value for crown length and the lower slope value for crown radius kind of balance each other, so that the scaling of the volume is the same on the sides. So this indicates that trees maintain the same balance between crown volume and the tree height, so during growth, essentially. So to wrap things up, we observed an earlier start of the season in lower sites, as expected. We observed significant differences in temperature, but break in growth between the sites. And we observed that these differences do not affect the allometric scaling of several plant trait parameters. So we propose this as a simple and easily replicable method to assess biomass partitioning in response to various environmental factors. And that's all. Thank you for your attention.
Merci beaucoup. Merci Claudio.